charts yesterday. Okay, the first one was this one. We wrote down the metals that we learned about, and then we wrote a plus if they attracted to a magnet. So the first one was iron, and we said yes, it does attract. Steel attracts to a magnet. Cobalt attracts to a magnet, and also nickel attracts to a magnet, right? We also looked at the author's organization. So let's look at our chart and see what we remember about yesterday, okay? So we remember that first he talks about what they're made out of. It's those four metals we just talked about: iron, steel, cobalt, and nickel. And then we talked about what they attract, which is the same kind of metals: iron, steel, cobalt, and nickel. We talked about different shapes, like the horseshoe shape that they are. So we can look and we can see kind of what we might hear today. Remember we talked that we would learn about a compass, that magnets have poles, that magnets, you can make your own magnet, and then how you can use magnets. Okay, so that is probably what we're going to hear about when we read the second half of our book today. What Magnets Can Do, written by Alan Fowler. We read the first half of this book yesterday, so we're going to start and pick back up where we left off yesterday. But every magnet, no matter what its shape, has a north pole and a south pole. Let's place two bar magnets with the north pole of one close to the south pole of the other. What happens? The magnets attract each other and stick together. What else can you think of that has a north pole and a south pole? The Earth does. Think about the way the Earth looks. The top part of the Earth is the North Pole, and the very bottom is the South Pole. So, do you think that the Earth could be a kind of a magnet? Think about if you drop something. What happens? It falls down to the ground, doesn't it? So, the Earth works kind of like a magnet. It pulls stuff down to it, but it pulls everything, not just metal. In fact, it's pulling us to it right now. That's how we're staying on the ground and not floating up in space. If we turn one of them around, magnets repel each other. They push each other away. Look closely at the letters on these magnets. Both are N's. If they are both north, the two magnets will repel each other. Repel means they push each other away. If one is south and one is north, then they attract or pull each other tightly. So what do you think would happen if both of the south poles came together? Well, they would repel each other the same way. You have to have one north pole and one south pole for two magnets to attract. The two same poles will always repel each other. Here is another way to see these magnetic forces. Hang one magnet from a string. Hold another magnet in your hand. Bring it slowly toward the hanging magnet. And what happens? What happens after you turn one of the magnets around? This is asking kind of the same question as we were just talking about on the other page, right? So if you take the magnet and you put it closer to the magnet on the string, and both of them are north poles or both of them are south poles, they're the same, what's going to happen? They're going to repel. But if you turn one of them around so that they're different sides, one north and one south, then they'll attract to each other. The needle of a pocket compass is simply a magnet. A pilot uses a compass to make sure his plane is going in the right direction. So does the captain of a ship. A compass needle always points north. Here's why. The Earth itself is a huge magnet, and like any magnet, the Earth has a north pole and a south pole. The Earth's north magnetic pole attracts one end of the compass needle. Try turning your pocket compass around. The needle will still point north. Okay, so we've already talked about how the Earth is really just a giant magnet. The compass needle can turn in any direction, but it always swings around so that it points north, and that's how we can use a compass to find our direction. Some magnets can be turned on and off. When an electric current runs through this wire, the iron bar inside the wire becomes a magnet, an electromagnet. What do you think would happen if you took the wires and the battery away? Well, you would still have a metal bar, but would it still be a magnet? No, it needs that electric current to become an electromagnet. Otherwise, it's just a piece of metal. Do you think that a magnet could be strong enough to lift up a whole car? Think about it. Touch your nose if you think it is, and let's find out. This crane uses an electromagnet to pick up heavy pieces of metal. When the crane operator wants to drop the metal on a pile, he just turns off the electric current. There are many hidden magnets in your home. They help your TV and VCR and computer game work. And they're inside your stereo, telephone, vacuum cleaner, refrigerator, washing machine, and other things that run on electricity. You can make a magnet yourself. Pick up a paper clip with an ordinary magnet. Now see how a second paper clip sticks to the first one. As long as the first clip is touching the magnet, it becomes a magnet itself. How long a chain of magnetized paper clips can you make? There are a lot of very interesting facts or a lot of interesting information about magnets in this book. Let's summarize it. So when we summarize, we think about the most important ideas. Okay, I'm going to start. So first we learned that a magnet is made out of one of these metals, right? Either an iron or steel or cobalt or nickel, right? And a magnet has a north pole and a south pole. We could also talk about how a magnet can be different shapes, how we can use it as a compass. We could say that our book also taught us how to make our own magnets. Remember that this book was written by Alan Fowler? Well, why do you think the reason was that he decided to write this book? Why would an author write a book about magnets? It's not telling us a story. He wanted to do what? He wanted to teach us about magnets. Let's go back and add some of the details we just talked about into our story map. Okay, we also learned that magnets have two poles, right? They have a north and south pole, just like the Earth, because remember the Earth is just a giant magnet. We learned that for magnets to attract to each other, they have to be the opposite sides. That means one needs to be north and one needs to be south. It also means that if it's two north sides, they won't attract to each other. Instead, they'll repel, right? We learned about compasses too. We learned that a compass needle always points north, and that's how it helps us to find our way, find our direction, doesn't it? Okay, it's always going to point us north on a compass, because remember, the Earth's just a giant magnet, so it's attracted towards the north, okay? We learned how people use magnets. There's magnets in our TVs, in our stereos. There's magnets in our in that giant crane. Remember that was holding the car? There's all kinds of cool ways that we use magnets every day. We also learned we could make a magnet by holding up a paper clip to a magnet, and the paper clip would become a magnet too, as long as it stayed touching the magnet. Okay? Now, I want you to go and watch the next video about magnets.